Hello everyone. In this lesson, we are going to learn how robots can be used to explore math concepts with children aged 6 to 8. As we have seen in previous sessions, representing mathematical ideas with materials is an essential component of early years mathematics learning. And the materialization process can happen through working with robots. When solving robot problems, children need to understand the problem, develop conjectures, test them and, if wrong, rethink their conjectures. Problem-based learning is an educational strategy that allows students to be actively engaged in finding answers by themselves. Improving problem-solving skills is one of the essential promises of problem-based learning. Learning by problems increases engagement of children, and interdisciplinary learning places learning in real contexts, allows children to learn to share knowledge and to learn in a collaborative way, develops the communication capacity of their ideas by making learning more contextualized and meaningful for them. Problem solving is a transversal skill to be developed throughout mathematics learning and a fundamental way to develop mathematical knowledge. Solving a problem is a process that requires finding a means to an end that is not immediately attainable. In this type of task, children should start by understanding the problem, design a plan to solve it, implement the plan, evaluate the plan and communicate the strategies tested or used. When working on computational thinking, coding, and robots with children, several authors highlight the importance of starting to work in unplugged approaches, using draws, models, storytelling or role-play techniques, as children show greater confidence about their abilities to understand the concepts involved. Unplugged activities involve fewer cognitive challenges and less technical knowledge that gives freedom to develop, in a first phase, other skills that are more meaningful to the children. Then they can work with tasks where they already program robots in computer software, for example, in a plugged approach. So, it's very important to know how to choose good problems, which should be authentic, relevant to children and challenging problems that relate different ideas and strategies. Contexts with good problems can help reduce anxiety in learning mathematics. Good problem-solving tasks stimulate students to reflect and communicate and can arise from students' own life experiences, or from purely mathematical contexts. In this session, we will discuss how students will explore, analyze and assess a set of activities based on a problem-based approach. Activities will answer the challenge of the plan, design a vegetable garden and develop the best strategies to care for it with the ground DOC robot. Then, students will reflect on the potential of robotics and real-life scenarios to learn mathematical topics such as addition, multiplication, measurement or geometric shapes and design possible didactical approach. In this proposal, students work on plugged and unplugged tasks, starting the work with unplugged tasks. This task leads the children to compose and decompose plane figures in a logic of paving a space that serves as a basis for the creation of the vegetable garden and gives the opportunity to identify and compare the figures chosen for each space. Children can also calculate the length measure of each robot move, such as moving on and moving backwards, and estimate the length measure of each side of the geometric figures. After recognizing their properties, they can plan the movement of the robot to go around each of them and develop spatial sense, namely through the perception of spatial relationships. In the first step, they can use a symbolic programming language that represents the predictable movements of the robot. It's also a proposal that can lead to the use of basic facts of operations in calculation situations and to the understanding of properties of operations by counting the number of vegetables that can be planted in each space, using number compositions and decompositions and the length estimation of the line that the robot travels around each of the vegetable beds, developing the spatial visualization. For this session, the learning outcomes are to explore problem-based learning as a way to work with robotics and deal with math anxiety, to understand the importance of working with unplugged and plugged activities to promote computational thinking, to pinpoint math curricular subjects to design teaching learning activities with robots, to explore and recognize the use of robots to foster learning about location and orientation in space, geometric figures, distance and length, and addition and multiplication, to reflect on the different didactic approaches to work with robots with children aged 6 to 8 years old. For more information, you can visit our project website www.mindmaths.org and see the output section to reach various topics regarding the use of robotics and other technologies in primary school mathematics lessons.